The chassis design starts with defining a coordinate system and reference geometry such as planes and axes which help orient the model. It's important to set up a plane for the vehicle's centerline as the chassis is symmetric, as well as for the floor and the primary roll hoop plane. Additional planes can be created to reference the ground and secondary roll hoops, as these will form hard points in the design. These planes are made visible, and planes for the front and rear axles defining the wheelbase are also shown. Creating sketches that reference planes allows for flexibility for rapid design adjustments to the wheelbase and structure without requiring lots of rework. We'll show these planes and move on to the roll hoops. 3 roll hoops have been created for the main, mid and front protective members, forming the ribbed structure of the chassis cockpit and front bulkhead. 3D sketches are used to curve the sketch in 2 directions for the front roll hoop. The sketch points are defined according to the Formula Student rules for minimum height, and the 2 front roll hoops are offset from the ground, creating a step in the chassis profile. To join the roll hoops, another 3D sketch can be created by strategically connecting nodes of one hoop sketch to another hoop sketch in order to create the frame members that make up the front bulkhead. Let's take a closer look at the front section. Here we can see how nodes have been connected to form an X-brace pattern at the suspension mounting points. All nodes are connected by 3 or more points, and where this is not possible, such as on the left-hand side, these will be braced further when the cockpit area is designed, in order to help transfer any frontal impact loads through the chassis of the vehicle in a controlled manner. At the top, another member helps support and add longitudinal stiffness and form mounting points for the body panels and other equipment. A custom isometric view of the front has been created, which will be referenced throughout this design. We see 2 members that are inset and used to mount the pedal box. The chassis is symmetrical about the longitudinal direction. In the lateral direction, bracing has been added in the 3D sketch to create members at the lower front suspension points from side to side, forming a suspension box which creates tight integration between the suspension and the chassis frame. A similar process has been followed to design the frame members in the cockpit area. Members have been triangulated around the 95th percentile driver template, also known as PERSI. Let's take a closer look at the model. The cockpit ergonomics are based around PERSI's inclination position, with a member running parallel to his back. The hip joint is placed as low as possible and the legs extended almost straight for best centre of mass position and comfort. The hands are also in the position where the steering wheel would mount, necessitating the need to bend the mid-roll hoop. The impact brace conforms to the Formula Student rules and is around 350mm off the ground. We also see a reinforced V-brace that transfers loads to the ground or rear of the structure effectively from the front bulkhead. The rear bulkhead follows a similar methodology, and we will look at the considerations for building this in more detail. We'll switch over to a rear isometric view, and we can see that half the chassis has been created and is trimmed at the centerline plane. A powerful tool when designing using 3D sketches is the ability to mirror 3D entities, saving time and effort and minimizing errors. To do this, we will edit the rear bulkhead sketch and group select from right to left over all the entities in the front view. We can then navigate to the Mirror Entities option on the sketch toolbar and pick the vehicle centerline plane to copy over. We can then see a preview in the rear view and accept the changes to complete the design. Whilst the operation completes successfully, there are some conflicts and warnings in the end result. This might be something you encounter yourself when designing a model. However, we can use the Sketch Expert tool in SolidWorks to help us out by clicking the red text in the bottom right corner and diagnosing the problem automatically. Sketch Expert will run through all conflicts and possible outcomes and provide a number of solutions. In this case, solution 1 highlights that there is a duplicate midpoint which is shared in the center and cannot be mirrored on top of itself. Clicking and accepting, we will delete this point and this should resolve the issue. As we can see, this is exactly what happens. We'll now exit the tool and proceed to see the final sketch entities and frame design. At the rear of this chassis, members have been oriented to create a support cradle that will house the KTM motorbike engine and mount it as a rigid, load-bearing component for added stiffness. Ingress and egress clearances have been considered for the drivetrain brackets and the chain, and the engine itself has members supporting it that are braced from the floor upwards. Nodal points have been imported using a macro to create the engine mounting points and can be used to design around. Reviewing the design, we can see that the frame structure is mostly complete and braced according to the rules. We can hide some of the sketches and show the double wishbone suspension sketch. This was created by importing points and linking them to build a wireframe model of the suspension system. We can see the nodes do not line up exactly with the frame, and this is due to clearance considerations for tube diameters, welding and mounting brackets. However, the points do form a 4-point box that the chassis accommodates and has been designed in accommodation with. This is crucial for any vehicle design, and using planes to base our sketches on allows us to quickly update positional information in a robust manner without breaking the model. Similarly, the rear suspension mounts are close to nodal positions on the rear bulkhead. Both sketches also include wheel axle locations. The upper wishbone is in line with the member bracing the engine to help transfer loads to the rigid engine block rather than the chassis frame. 2 wheel sketches are included to complete the design and validate clearances later on. A tip to help differentiate multiple sketches is to right-click and assign a sketch color, which is often overlooked but does help. Axis reference geometry can also be inserted, and here the 2 main cockpit ingress template bodies have been modelled and positioned in the respective locations determined by the scrutineering section of the rulebook. Again, this helps validate the design.